Okay, so now let us work on question C. When I say lettuce, it sounds like lettuce and tomato, but whatever. Okay, so I'm going to use yellow for this one. Question C. What is the work done by the gravitational force? Okay. So we go back to the free body diagram, right? So the gravitational force, in this case, it has to do with the weight, right? However, let's say if the rope snapped, this person would slide down the incline. So we want the gravitational force, which is parallel to the surface, or mgx. That's the one we're after, right? Because that's how gravity is. That is the component of gravity which matches the direction of motion. This one's with the motion. With the motion, okay? So I'm going to copy the given. And uh-oh, I didn't change it to black. This is question C as in Charlie. And now we have to find the work done by the force of gravity. Actually, yes, I'm going to write this one. Erase, work done by tension, and copy it. A little bit smaller because it's not going to fit. I knew this one was not going to fit. There you go. What is the work done by the force of gravity? In this case, the force of gravity, based on our free body diagram, right, is the component of gravity that matches the motion. If this was free falling, then mg would be the force of gravity. In this case, we want the component that matches the motion, which is mgx. Wait, which is mg. Hey, what happened? There you go, mgx, this one. That's the one we want, okay? So this will be work done by mgx. That's the force, right? That's the weight component along the x direction. This is the force. Okay? So then the work done by force of gravity is equal to mgx, that's the force, times distance times the cosine of theta. Do we know what mgx is? Yes, we do. Is mg sine theta. So then we can say work done by friction, by force of gravity is mg sine theta times the distance times the cosine of theta. Mg sine alpha times distance times cosine of theta. So how do we know what theta is? Well, now we take the direction of motion and we compare direction of motion with the vector for mgx. So what is the distance from the end of the direction of motion, the green arrow, to the tip of the mgx vector? But they are on top of each other. I cannot move, right? When I had the force of friction, I could move this way, but now they're in the same spot. So I cannot move. 0 degrees, there's no space. So this is 0 degrees. And the wrong one, there you go. So it is 0 degrees. Now we're maximizing the force with the motion, okay? Again, like I said, when you have an inclined plane, the force that is against the direction of motion, if you have a force against the direction of motion, theta is 180. If you have a force with the direction of motion, theta is 0. So in this case, theta is 0 degrees. And we know the cosine of 0 is 1. So we'll have work done by the force of friction is equal to mg. I'm going to move the d over here because I want my letters to be together. D times the sine of alpha times the cosine of 0. That'll be times 1. If it is times 1, I don't even have to write it down again, right? Because this is equal to 1. Equal, not equal, just 1. And I write that the work done by the force of gravity is mgd sine alpha. And now we have everything we need. Mass, acceleration due to gravity, and sine of alpha. This was a little shorter than the other ones because we did all the work, especially for question A. And so I think we can get question D out of the way. Okay, and it's super simple. So question D. They want to know what is the net work done, the total work, right, on the system. If you want to find the net work, we need the net force. F net times distance times the cosine of theta. Okay? So how do we know what the net force is? You can go to the summation of forces. That tells you exactly what it is. However, you can just look at the fact that this person is moving at a constant speed. Okay? So if this person is moving at a constant speed, what that means is, don't forget that speed is the scalar of velocity. Speed is how fast, and when you make it velocity, it's how fast and where. So at constant speed, it means that velocity is constant. If velocity is constant, there's no change in velocity, right? We have no change in velocity. If we have no change in velocity, that means we have no acceleration. Again, think about cruise control. You're not accelerating. You don't even have to press the gas or the accelerator. No acceleration. If we have no acceleration, because force is equals mass times acceleration, we have no force. So then if we have no force, then 0 times d times the cosine of theta, whatever they are, then it would be 0, right, because there's no force, times d times cosine of theta. The net work done is 0 joules. Again, the fact that the net work is 0 doesn't mean that we don't have different forces doing different types of work, right? This one's positive work because it's with the motion. This one is negative work, which is against the motion, and then friction is negative work because it's against the motion. But since the system shows no acceleration because you have constant speed, then the net work is 0 joules. And that's it.